I'm going to have to start swiftly here because unlike the SQL Azure sessions where we finish slightly early, we might be struggling to finish in an hour here. Okay, so I'm going to have to go at a reasonable pace, but I don't want you to not be able to ask me questions, so do so as we're going along. Okay, so we're now down into the fourth bit of the Windows Azure platform. This is the AppFabric bit, not to be confused with Windows Server AppFabric, cunningly named with the same name. A slightly different offering here. The AppFabric part of Windows Azure is really all about two things. It's about connectivity. It's about building, giving you the building blocks to build connected applications, whether those are on-premise applications or cloud-based applications, to allow you to build out hybrid applications that make use of both cloud-based functionality and on-premise-based functionality, to give you mechanisms for making it easier for authorization within your applications so that you don't have to rewrite really complicated authorization logic over and over and over and over again like we do. And also to give us a way of getting around some of the issues that we have, particularly with state management, inside our Windows Azure applications. And this isn't really the end of the story with AppFabric. There are an awful lot of extras coming along, so we're going to have more control over things like Windows Workflow. We're going to have better integration functionality between on-premise and cloud-based apps. And they're going to extend this into even more functionality around WCF. But at the moment, we have three very distinct and interesting and separate parts of Windows Azure AppFabric. And those three parts are the service bus, which we're going to start with, access control service, which is all around authorization, which we will do second, and then the caching service, which, as its name suggests, must have something to do with caching, which we'll talk about at the end. All of these parts of AppFabric actually come from down here. I know that if you're sitting at the back, that's probably really hard to see. Yeah, so this is the service bus, access control, and caching section of the portal. And you'll notice at the top, I have my three distinctly different parts. I have the service bus, I have access control, and I have caching. And I will explain all of this other content as we go through in a minute. So, when I go back to my PowerPoint over here, let's start with the service bus. Okay, the service bus really provides us with a number of mechanisms for secure, reliable messaging and connectivity across cloud-based applications or between on-premise applications and cloud-based applications. And essentially it gives us a way of talking to services that we provide, again, either as cloud-based or as line-of-business applications, perhaps on-premise, talking to those back-end services over HTTP or talking to them over TCP, giving us a mechanism to take away some of the complexity that exists between getting a client application to talk to a service application, irrespective of where that client is running and irrespective of where that service is running. And really this is the type of application and connectivity between apps that everybody is looking for these days. I want to be able to run an app on any device I like, and I want to be able to talk to a service that's running in the back end, either perhaps behind my firewalls or perhaps running in the cloud. And I want to be able to talk to that service and get information from that service, do it reliably, do it securely, do it any time I want, every time I want, from anywhere I want. And building out that type of application can be quite a challenge which the service bus actually addresses very well. So, first things first. If you're going to use the service bus, it's important to recognise there are really three ways that the service bus works. The first is to use this thing called the service bus relay. Service bus relay is essentially a communication between some cloud or on-premise application, and again that could be any cloud or on-premise application, doesn't have to be something written in Visual Studio, it can be anything that I've got running anywhere, talking to some on-premise, potentially application that's in this case running as a WCF service, drilling through all of my firewall issues, ignoring all of the issues we have around network address translation and all that horror, relaying messages between a client of some description on some device and a service of some description running perhaps on-premise or in the cloud, up to you. Okay, so it's about relaying messages between the cloud and, for now, let's say an on-premise application. Not just relaying the messages, but actually passing the messages backwards and forwards so that we get proper client service type functionality. You'll see on this little slide here, it says, at the top it says Service Bus Namespace. And you think, what on earth is the Service Bus Namespace? And how has that got anything to do with what I'm talking about with Service Bus? Well, let me go to my portal again, and you'll see in my Service Bus section, up at the top here, I have my two little braces. Yeah, the QA AppFabric namespace. And you'll notice up at the top left-hand side, I can create or modify service namespaces. What do these service namespaces really represent? They represent an endpoint in the cloud. They represent somewhere that has a URL of HTTP, let's say, QAAppFabric.servicebus.windows.net. Okay, they're a root namespace for endpoints that I want to create up in the cloud. And those endpoints that I create and use up in the cloud will be known by my client applications and will be known by my service applications and will be effectively a relay point sitting in the cloud that allows messages to pass from the client to the relay, back down to the service, and perhaps back from the service, back to the relay, back to the client. Now you might be thinking, well, there's nothing clever in that particularly, but actually what we do is we, from both the service and the client, we're going to open outbound channels, outbound sockets, saying I want to connect to this point in the cloud, this HTTP endpoint or this TCP endpoint up in the cloud. And because I have an outbound communication, I can message across that communication without having to worry about firewalls and all the things that get in the way of when I'm trying to talk about messaging between client and service. So the Service Bus namespace, in my case QA AppFabric, is actually fully qualified as Transport Protocol service namespace.servicebus.windows.net, followed by a series of endpoints that both the service and the client know about. And I hope that's making some sense, because it makes sense to me, but I'm not certain it makes sense to you. Okay? So, when I'm working with Service Bus Relay, then, what I'm really talking about is this type of idea. So, applications that client and service want to talk to each other, my endpoint sitting up in the cloud in the Service Bus, SB, I might also make use of another part of AppFabric called the Access Control Service, which is my ACS here, but that's not compulsory. But it might be that my service, perhaps running on-premise, opens up and talks to the Access Control Service and defines a set of rules for authorization. It then opens up a connection to the service bus and exposes connectivity to the service via the service bus. I'll show you how we do all of this. My client device, my client application running on any device, anywhere, anytime in the world, perhaps then talks to the Access Control Service to be given some kind of claims that it can use to access the back-end service. It then accesses the same relay endpoint in the service bus, passing messages between the client app and the line of business service. The line of business service does whatever it's got to do, perhaps sends an answer back to the client, and possibly, if the devices can talk to each other without going through the service bus, we can ask for them to communicate now without going through the relay of the service bus, thereby not incurring any cost. Because cost with AppFabric is all based around transactions, either through the service bus or through the Access Control Service. Okay? So essentially with Relay, we have this ability to relay messages through this endpoint up in the cloud yeah, that just exposes a common place that both client and service trust to talk to each other and pass those messages between each other. Here's a little example. If I go to my virtual machine, it's not that example, it's this example. Okay, is that big enough to read at the back, guys, by the way? Yeah, it's big enough to see? Okay. Now, I don't want to spend a whole world of pain on loads and loads of code here, but you never know, you might quite like a bit of code. You'll notice right up at the top here, this is a service that I have running. So this is actually the Twitter service bus service. Okay, it's something to do with Twitter, clearly, and it's something to do with being a service that's going to be exposed through the service bus, hence the name. And for those of you guys who do WCF, there's probably not going to be too much that's too difficult here. But you'll notice up at the top of my code in my service, it is a console app. Yeah, so it's going to sit and run as a console app in my client. And you'll see that I have a service namespace domain of QA AppFabric. You perhaps recognize that name, yeah, as being something that I had inside my service bus configuration in Azure. I'm hoping you remember that name, QA AppFabric. I'm hoping that you don't remember the issuer secret, but that's probably a little bit trickier to remember. But you'll see that I have an issuer name, a key, and I have an issuer secret. Yeah. I'm not suggesting to you that you should hard code these into your code. I'm just demonstrating the fact that I have a key and I have a secret that I can use to allow my connection through to the service bus. If I go back and look in my QA AppFabric, yeah, here's QA AppFabric, you'll notice down at the bottom, hard to see at the back I know, but there is a management key, and it says at the moment that it is hidden. And if I was to click on it, it will show me that my management key is oh look, starts HRSXH and ends in 697U equals. Where is that being used? It's being used over here, HRSXH ends in 697U equals. Okay, so the management keys for my namespace are a way that I can use to provide some level of security for talking to that namespace. Okay, a bit more lines of code. What we have here, if I scroll across a little bit, you'll see that I have the service bus environment class has this method create service URI. The create service URI allows me to create an endpoint in the cloud based around the root namespace. So in this case, I'm going to create a URI that starts with the letters SB:// a small prize for those of you who might be able to suggest what SB stands for, followed by the service namespace domain, followed by a very simple endpoint called Twitter service. What I'm really going to do is I'm going to build in the service bus an endpoint that says SB:// QA@fabric.servicebus.windows.net/Twitter service. Okay, so I'm going to build and expose this endpoint that's going to sit up in the data center in Dublin, and allow me to talk to that endpoint from my client applications. Are we making sense so far, guys? Yeah? Cool. I have all sorts of very primitive code about my token provider being able to provide the correct security credentials. Yeah, but eventually I am going to open up a connection to my host saying I want clients to be able to connect to this service through that endpoint. So when I run my console app, that is the service is responsible for opening up the connection in the service bus. Not the client, the service. That kind of makes some sense, doesn't it? Because I don't want the clients to be able to open up loads and loads of connections through the service bus. I want the service to expose its functionality through the service bus. And so my my service will now sit and wait. Just because it's a console app doesn't mean anything at all. This could be a WCF service. It could be any kind of service that's just sitting, waiting, asking for messages. Well, not even asking for messages, just expecting messages. Okay. Now, the Twitter service in its own right, if I go into my Twitter service, again, I'm not going to bore you with a great deal of detail here, but effectively it makes use of a service that I can call from Twitter, which says, if I give you my username and my password, and I give you somebody else's username, the friendships service from Twitter will tell me whether that person is following me or not. And it'll send back a little chunk of XML that I can read to say, yes, that person's following me, I'm really interested, that's fantastic. Yeah? So essentially the Twitter service, with its check if user follow me method, basically just says, yes, the person follows you, or no, they don't follow you. Right? No point taking you through loads of code here, that's just what it does. So, when I look in the app config for this service, and again, those of you guys who do WCF at the minute, you won't be too frightened by some of this. I have an endpoint that has a binding type defined as NetTCP relay binding. Those of you guys who do WCF, you're probably familiar with NetTCP binding. Yeah? I'm going to talk to you across TCP. Strangely, NetTCP relay binding means I'm going to talk to you across TCP, but I'm going to do it through the service bus, the word relay. So really my binding is just saying I want to talk to the service bus. And you'll find that all of the on-premise bindings have similar relay bindings, where the name has just changed to HTTP relay binding. Okay? So I can configure my service to say I want to open up the connectivity to the service bus, and now I want clients to be able to talk to me through the Twitter service endpoint that I've created programmatically. If I look in the console client, I have the same sort of idea. So here's my app config again. It too knows about the NetTCP relay binding type. And if I go to the program.cs, it has a very similar set of code. Yes, it has the service namespace domain. Yes, the same set of credentials. Yes, the same thing to create the service URI at the same endpoint. If I go to my expansion over here, aha, I want to talk to the same endpoint as has been exposed by my service. And you might be sitting there thinking, well, how does the application know about that? Who is it that told the application about that? The client. Well, you have to put yourselves in the real world here and say, I'm exposing a service, so I'm probably going to tell people who want to consume my service where that thing is going to be exposed. Or if I'm writing the app that's going to connect to that service, of course I know where that thing is going to be exposed. So it's not some kind of witchcraft. The client knows how to connect to the service. Right, the same sorts of stories all the way down here. Basically then saying, this is my username in Twitter, MS Class Finder, just so that you know, guys, I don't use Twitter. Anybody use Twitter? Okay, some Twitter going on. Might ask you to be a friend in a minute if you can log in. I don't use Twitter, I only use it for this demo. Right, so don't expect me to find me under MS Class Finder because I don't tweet a lot. Okay, I've been at least half decent this time saying please get me the Twitter password value from the config file. At least I haven't hard-coded that for you this time. And so now my client is going to say to me, right, okay, welcome to the Twitter client, give me your friend's Twitter name. I've already got your password, I already know who you are. Go away and call out through the channel to the service, call the check if user follow me method, and get the answer back and display it. Okay, so now here what I'm doing is very, very simple relay. I've got a service that is exposing an endpoint. The service has a method that calls out to Twitter. The client connects to the service by passing a message through the relay, goes to the service. The service says, thank you very much for those method values, those parameters. I will call out to Twitter, find the answer, and give you the answer back through the relay. Does that make sense? Is that a resounding yes? I hope so. Yeah? You see the plan here. Just because this is a console client doesn't mean to say it couldn't be any other kind of client. It could be, as I have over there, a Twitter Service Bus Windows client. It could be an application running on my phone. It could be a Java app. It could be any kind of app running on any device, anywhere, and I can have millions of connecting clients and deal with their requests in a properly scaled way because I'm using the service bus, not using my own on-premise kit to deal with that messaging. Okay, so designed to work at scale. If I run my service, let's go and debug and start a new instance of this service. Up will come the service. It will say, in a minute it will say, I have opened up a channel 2 SB, QA@fabric.servicebus.windows.net Twitter service. And now, of course, it's just going to sit. All it's doing is waiting for clients to connect. I could open up a console client. We haven't got time to wait while that boots up again. We will get back to it, but don't worry. So, applications using the service bus, nice and straightforward. What's going on here? Yes, we've just talked about that. Yeah. However, if that was all the service bus could do, if it was just about relaying content backwards and forwards from client to services at scale and at speed, that would be fine. But actually, in the latest incarnation of the service bus, things have got even better. For example, we now have the concept of queues. Proper queues. Please don't think these are Windows Azure storage queues, right? Because they're not. These are service bus queues. Different kind of queue. I can have many different types of sender of messages. And I could have millions of instances of these applications. Maybe they're Azure apps, maybe they're on-premise apps, maybe they're web apps, maybe they're console apps, maybe they're phone apps. You know what? It doesn't matter what they are kind of app. Yeah? They are just loads and loads and loads of message senders that send messages to a service bus queue, which is a proper first in, first out queue, and then my service or my application that's running at the back end can pull those messages from the queue, knowing that the order that they're coming out is the order in which they went in. Okay, so now rather than just having a relay endpoint that I have in the cloud, I have a queue where I can just fire and forget my messages. If place this order, update this person's details, fold this into an origami kangaroo. It doesn't matter what it is. Yeah, the message goes into the queue and I can guarantee that it will come out in the order that it went in. Okay, so queues, as we'll see in a minute, very useful and easy to do. And what's going on here? Still starting. Okay? So, we have queues. There are differences between Windows Azure queues and Service Bus queues. So, for example, a Windows Azure queue, it is not necessarily first in, first out. I think you probably got that from what I was saying this morning. You know, yes, I can read a message from the queue, but I may still be processing this one while the second one just gets processed and dealt with. Yeah? So although I'm going down the queue to get the items, yeah, I may have finished processing the second or third or fourth or fifth before I finish processing the first. Yeah? Whereas a service bus queue is absolutely first in, first out. Do both guarantee delivery? Yes, they do. With a Windows Azure queue at least once, yeah, with a service bus queue at least once, and I could also say at least most, many. Yes, sir.
Is batching supporting in service bus queues?
Say again, sorry.
Batching, so we can pull, like for example, 10 messages at a time, not only one. Because if we talk about paying by transaction, then it's it's better to pull like 10 messages or 20 messages at a time instead of one, because it's counted like one transaction.
Yes, absolutely. And when I come down here, yes, I can do transactional stuff. So I can have batches and I can do things transactionally. Absolutely. So I could say, go away and pull me 50 messages. Yeah, or go away and pull me 10. Yeah, absolutely. Okay. Other differences, we have the possibility with a service bus queue is you can both look at and lock it like you do with a peek and lease inside the service bus, inside the Windows Azure queue, but you can also have a receive and delete. Yeah, so you're basically saying get it, and as soon as you've got it, delete it. Yeah, slightly different mechanism. Different lock durations and lease durations. Yeah, so Windows Azure queue. Yeah, 30 seconds is the default lock, 7 days is the maximum, time to live is 7 days maximum. Yeah, similarly, service bus queue, 60 seconds default, you can change it, 5 minutes maximum. Yeah, time to live 1 hour is default, but actually you can have it there for months. Yeah, so different levels of functionality, different degrees of service. Okay, so now what I'm going to do is I'm actually going to run these, not from my virtual machine, because you might be thinking it's some kind of witchcraft through the virtual machine. Well, no. What I'll do is I'll run them as real apps, yeah, sitting on my real desktop. That way at least it won't crash. Yeah, so again, this is the service that's going out. It will be exactly the same as we had before. Yeah, it should build the namespace for me. Should build the namespace for me. There we go. And if I run, let's say, the console client just for now, here comes the console client, and of course I could run my app here. It's already picked up the fact that I'm called MS Class Finder. It's going to ask me for my friend's Twitter name. Perfect timing. Guess who we're going to have? Lady Gag. Lady Gaga. I honestly don't think that Lady Gaga's following me. And absolutely no, she's not. It's not hard-coded. Right? Okay? But of course what that really means is that I can have as many of these as I like. Yeah, so I could run another one. In fact, I could run millions. I could run millions of clients of all different types, running on my phone, like in here. There's probably someone called Fred in Twitter. Yeah, Fred doesn't follow me either. In fact, probably no one follows me in Twitter because they don't know I'm there, and I've got nothing to say. But I could run as many of these different clients as I like. I can guarantee delivery to that service no matter what firewall you put in the way of me. I can guarantee it because that has opened up the connection to the service bus. Yeah, so I absolutely can guarantee I'll be able to talk to it. That's simple relay. We talked briefly a second ago about queues. There is another thing that we can do, as well as queues. We can create things called topics and subscriptions. And topics and subscriptions are another powerful way that we can start to use the service bus. Again, many different types of message sender, perhaps many different message receivers. Each of those receivers might want to receive and treat messages from the different message senders in different ways. And so what I can do is I can build out a thing called a topic that then says, if you send me a message and it's like this, yeah, then I want, in this case, the business logic message receiver to receive it. If you send me another message and it's kind of like this, then I want, in this case, the audit message receiver to action that message. So that I can start to build out rules that say, here are my services, my clients will send messages, the different messages will be routed to the right message receiver and processed in the right way by that message receiver. Does that make some sense, guys? Yeah. For example, if I go back into my virtual machine, not there. Come on. Got all day for this. Where's he gone? Here he is. If I go into my virtual machine, let me just open up, firstly, the topic, and then we'll do a queue. You'll notice, whilst that's opening, that as I look in my portal, underneath the QA AppFabric service namespace, I have created a topic. The topic is called the QA Business Topic, and there are two subscriptions in it, one saying all messages, the other saying high priority. I actually didn't create those through here, although I could. They're actually created by the application that I'm going to run. So when I look over here, I have two components. I have the message receiver and the message sender. Okay, the message sender Very straightforward. If I go and look at my code here, here's my very straightforward message sender, basically looking at my service bus issuer and my service bus key, remember my owner and my key, pulling those values, creating my token provider, creating me the service URI at sbqa@fabric.servicebus.windows.net, etc., etc., and then coming down a bit, checking whether a particular topic exists, QA business topic, that was the one that I showed you in the portal a moment ago. If it does exist, sorry, if it doesn't exist, then make it, yeah, and at the same time also make me the subscriptions called QA business topic, all messages, and QA business topic, high priority. Those are the two subscriptions. You'll notice that the high priority filter says, I have a filter that says high priority equals 1. Okay, what does that actually mean? Well, if I look at the sender, if I go to the sender, nice and straightforward. Again, it's going to build out exactly the same kind of content, so it builds out the create service URI, checks whether the topic exists, yeah, comes along down, yeah, and talks about the filters and so on and so on. But then, when I send a message, I'm going to have a little checkbox that says if it's checked, then I want to set the property on the message called high priority to 1. Remember my SQL filter? High priority equals 1. Yeah? So a high priority message will now have a property called high priority and a value of 1. Otherwise, its high priority value will be 0. Okay? What are we really saying then? What we're saying is, in this scenario here, the all messages subscription should receive all messages. It should get messages that are high priority equals 0 and high priority equals 1. Yeah, whereas high priority messages will only be the messages that are high priority equals 1. Does that make some sense, guys? Yeah, we're okay? So, if I now go and run, and again I have these sitting locally, so let me go. What's going on here? What is going on here? Just infuriatingly difficult. Topics. Okay, if I go to the service, okay, and we run the service, that's the Twitter bus service, you idiot. Goodness me, service bus. Service bus applications, topics, message receiver, bin, debug, message receiver. Okay? The message receiver's job, remember, is just to pick up the messages from the different subscriptions, and it will display them either as a high priority message or as an all message, picking up the messages from the different subscriptions within the topic. Whereas my sender okay, my sender looks like this. Okay, I have my text rather. So let's say I have a low priority message, and we'll call it number 1. I will send it. It'll clear. I'll send a high priority message, and I'll send it. All of these messages being farmed off into the service bus, yeah, into the topic and the subscription. We'll have a low priority number 2, and we'll have a high priority number 2. So all my messages have now been funneled out into the service bus. They'll just sit there and wait until my service, yeah, is interested in receiving them. And in this particular case, I've said I'll have a button that says start receiving. In the real world, it wouldn't be like that, but that wouldn't be a very good demo. Yeah, so I'm actually going to do start receiving. It will now go away, and it will say, hopefully soon, here are all the messages that came through the all messages subscription, and those are the high priority messages that came through the high priority subscription. Now, this could be a service that updated rows in a SQL database on premise, or fired some more information into the cloud, or did whatever you wanted it to do. And the high priority messages could be messages that need to be treated in a slightly different way, or an additional way. Yeah, so that now I can start to route my messages and start to deal with my messages very straightforwardly and very efficiently. And I know as a client all I have to do is send them, and they are guaranteed to be picked up by the service bus and managed by the service. Does that make some sense, guys? I know we've had to go quite quickly there. Yes, sir?
Why does the sender have to create the subscription?
The sender doesn't have to. Yeah. Sorry, I'll rephrase the question. Why does the sender have to create the subscriptions? Actually, the sender doesn't have to. You could do that manually through the portal. I just did it through code because I just chose to do it that way. Yeah, absolutely. You don't have to do it that way. Yes, sir?
Do you have other ways of routing messages than arbitrary properties? Like schemas?
You can, but you have to be more creative about that in terms of how you define how you want those messages to be routed. So again, mine is a very trivial example that just has arbitrary properties, but you could route them according to all sorts of different application logic mechanisms. It's entirely up to you. Yeah. Okay. We're running out of time, guys, so do you mind if I don't show you the queues demo? It's the same, really. It just goes through a queue, that's all. Yeah, rather than through topics and subscriptions. Yeah, is that okay? Yeah. If you want to see it, we can do it afterwards, but we're probably going to run out of time if we're not careful. Okay. So, Service Bus. An absolutely fab way to cope with reliably delivering messages, whether that's through a queue, whether it's through topics and subscriptions, whether it's just through a simple relay. Yeah? Guaranteed to work at scale and at speed. Okay. Why has PowerPoint just died now? Okay, that takes us nicely to the access control service. The access control service is this. It's used to help you authenticate and authorize as users of your applications. Perhaps around things like single sign-on, perhaps around things like ADFS, perhaps around things like using Yahoo IDs, Facebook IDs, Google IDs, Live ID, or any combination of the above. Actually, this is not true anymore. Version 2 is available now. Yeah, version 1 was available ages ago, and version 2 is properly available now, and probably is the version that you should use. I don't know how good you guys are with security speak, okay, but if I say to you, an identity provider, yeah, that's someone that provides identity. Right, okay. Yes, that's something that says, I'm saying who you are. Yeah, like Google can provide a Google identity for you. Or Live ID can give you a live identity and say, these are your features. Okay? So I want you to imagine a world in which I have a browser and I'm trying to use an application. Over on the right-hand side. Maybe it's an application running in the cloud, maybe it's not. Frankly, it doesn't matter. I want to be able to limit or describe or determine what the person using the browser can do within my application. And I want to be able to define that or limit that based on some features of them. Maybe they're Active Directory features, maybe they're features based around their Live ID. Yeah, but they are features that identify them. So, what I could do is I could say, using my browser, I want to use your application, please. And that would be fine. Except, I've got absolutely no idea who you are, and I've got absolutely no idea what it is you want to do, and I've got absolutely no idea whether you should be able to do that thing, and that's not very good. For example, maybe my application allows people to buy scissors. A dangerous tool, and one in which, certainly in the UK, you have to be 18 to buy a set of scissors. Is that the same in Finland? No. It's 21 in Finland. It's not, is it? No. Okay, also, to buy a knife. I don't mean a knife, I mean a knife, you have to be 18. These are clearly dangerous tools that we must not let our teenagers out with. Here's a rifle. Would you like to join up? You only have to be 17 for that. Never mind. Sorry? So maybe my application needs to be able to let people buy scissors and chainsaws and stuff. And I need to know that they really shouldn't be able to do that if they're underage, for example. So I need to have some information about them to determine whether I should display some content and let them buy scissors and chainsaws. So, rather than just requesting the resource, my application can actually redirect my request for access to the app to an identity provider. So, Live ID, Yahoo, Facebook, Google, my Active Directory, whatever I'm interested in. And my identity provider can ask me to log in and provide the right credentials. At which point, it will give me a token and say, yeah, I know who you are. Here is your token that you can use, and pass to the Access Control Service. The Access Control Service says, thank you very much for your token. Given this token, you have already defined some rules about what the person can and cannot do, given this particular token. So the Access Control Service sits up in the cloud and issues another token that basically says, here you go, Mr. Browser, Mr. User, here is your Access Control Service token that I now want to redirect back to the application, back to the relying party, and say, here you go, here's my Access Control token, this says who I am, and you can work out from that what I should be able to do. And so my application then validates it and sends me back a resource that is appropriate for me. That's a security token service, the Access Control Service, isn't it? It's about providing things like SAML tokens. But it's a cloud-based security token service, so it runs at scale. That's what it's designed to do. How easy is it to set up? Let's go back to my portal. Here we go. So if I go in the Access Control Service, you'll see here I have two namespaces. This is version 1. This was the original version of the Access Control Service. This is version 2. I can look at that, and I can see that in this particular Access Control Service namespace, I can define different identity providers. So I can say I'm interested in having Yahoo or Google or whoever it might be. I can define that there are certain relying party applications that I might want to make use of the application, the Access Control Service. So I can look at a web app, for example, and I can say, where is the web app that wants to make use of the Access Control Service? I can have rules. And the rules might say, given from Yahoo, if you give me your email address and you give me your name and your name identifier, I can pass those values through to my relying party application, or if I sign in with a Windows Live ID, then I'll just pass through the name identifier to say who you are. So again, all of this is structured within the tokens that are given back by the different identity providers. So I can start to build out different identity providers, define different relying parties, say what different rule groups apply, and then maybe what I could do is I could start to work with my different schemas to allow me to use that data inside my applications. So I can build out content through the portal. I can build out content through the portal. Where have you gone now? Go away. You going to do it for me? No, you're not. Excellent. Have I still got one? There we go. Thank you very much. Sorry. You're going to go there for me? Yes, it is. So I can start to build out the rules, if you like, that apply for the issue of my tokens, and then use those tokens inside my applications. Now, I'm not saying to you that you don't have to write some code. to interrogate what's in the tokens. And I'm not saying to you that you don't have to write some code that validates the tokens, but at least you only have to write it once, not time after time after time after time in all your different applications. Yeah, I mean, writing authorization and authentication code is just not nice at the best of times. Just being able to write it once is an awful lot better. Well, I think it's better. Okay. Questions, guys? Uh-huh. Oh, sorry.
How about the situation where you're buying knives? So you would need some official identity provider.
I would, and maybe I'd have to write that myself. Maybe I'd have to write those rules myself that said, actually what I need to do is pick up how old this person is. Yeah, absolutely. And I need those people to sign in and give me their details. And okay, they could have lied to me about how old they were when they first signed up. But you know what? That's not necessarily too much of my problem. That's more their problem than my problem. Because they are dangerous, those knives. Okay, so access control. Oops, sorry. Sits with all of the different types of SAML tokens you might use. You can use things like OAuth, WS Trust, Federation. Integrates nicely with Windows Identity Foundation. Integrates with ADFS. Yeah, all of those kinds of levels of support for you. Caching. The caching service is this. It is a distributed in-memory cache for applications that are Windows Azure applications. Those applications could be web front ends, web roles, WCF services, and so on and so on. And as we talked about this morning, those applications are inherently stateless. And people don't often like writing inherently stateless applications. They much prefer to have some kind of state management to deal with. But of course the Azure platform and Windows Azure isn't like that. Yeah, it's designed to be scalable, and scalability and state don't necessarily go hand in hand. So the caching service gives us a way of very easily building out somewhere where we can cache content. That could be object caching, it could be page output caching, it could be session state caching, it could be any kind of caching that we want to make use of from within our Windows Azure applications. How do we do it? Well, again, we'd go to my portal, I'd go to my service bus access control and caching, and here you'll see I have the caching section. And in the caching section, I'm able to build out, same sort of story, I can build out myself a service namespace, in this case QA AppFabric cache. As I go into here, if I was to do a new one, yeah, it'll ask me, what's the namespace, where do you want the caching service to run, and what size of cache do you want to have. So everywhere from 128 meg all the way to 4 gigabytes. Yeah, so you're able to make use of this caching storage, yeah, to store objects or to store content that you want to cache. And again, that could be objects, it could be page output, it could be session state variables, it could be whatever you want it to be. How do you access it? Well, not too surprisingly, you access it by using the namespace. Yeah, so that we can talk to the cache in much the same way as we might talk to the service bus. Yeah, so you have this type of idea. Cache to disk, cache over the network, AppFabric caching, distributed cache. Maybe you're using a local cache. Yeah, all up to you. So either using storage or using AppFabric caching with a distributed cache, or using AppFabric caching with a local cache. Yeah, your choice of latency. There you go. So again, no limit to the size of the objects, no cost involved. You pay for the cache, obviously, but the cache can be used usually for session state and page output management. Questions, guys? Ah, yes, sorry.
How does this compare to the cache in ASP.NET?
Very similar sort of idea, So if you wanted to cache objects within your ASP.NET app, almost identical. So it's the same words. It's cache.add, cache.open. That type of idea.
But that's shared across all my web role instances, for instance.
It certainly could be, or you could just say that I want the cache to be a local cache just for this one instance. But if I want a distributed cache, then I can say it's distributed across all of these instances, and then each of my instances could actually access content from the cache in the kind of ASP.NET caching way. Yeah. So your choice. You can either have a local cache that's just for that instance, or you can have a distributed cache that all your instances can access. Has that made some kind of sense, guys? I appreciate that I've had to go relatively quickly through that bit.
But what's the cost for this?
Oh, sorry. Money. Heaven forbid we should talk about money. God. You can see I'm getting tired now. You won't be at all surprised to know, Mika, that it's based on the more you use, the more you have, the more it costs. So when I go down to my caching, here comes my caching. There he is. So caching. So different. So there we go. So if I have one 128 megabyte cache, then it costs me, what's that, $45 a month. If I have one 4 gigabyte cache, then it costs me $325 a month. So varying in between those.
Using the ASP.NET cache, that would use the memory of that instance.
Yes.
So you could make full use of the money now.
Yeah. But in a more distributed way, here I've got something that can span across all of my instances, and I can even get content from one instance, one application into another application if I need to. So not too pricey. I mean, when I said one on the 128, that you perhaps look at that and you think that's $45. But well, yes, but one 256 is only $55. So it's not a case of it's pro rata. And one 512 is $75, and so on and so on. 110. And obviously you can have as many as you like and spend as much as you want.
No limits.
Huh?
No limits on that.
Absolutely no limits at all. Well, the slider only goes to 20 of those, but $6,500 a month in caching, that's quite
Is
expensive.
that the 20 limit that you have to, after which you have to call?
I think that might be, I think after that they probably think, are you mad? How much stuff do you want to save?
Everything.
Everything, forever. Perhaps use it for my backups. Okay.
This review the backups.
Indeed. Has that made some kind of sense, guys? I do apologise for having to go quite quickly there. But I hope it's made some sense. Service Bus is all about connectivity. It's all about being able to provide secure, reliable, scalable ways to get your apps to talk to services. Access control is about authorization and authentication, and caching is about, I suppose, if nothing else, just improved performance.
What about the cost for access control if you just do a bit?
Yeah, absolutely. Well, access control is remarkably cheap, of course. So I can have 1 million access control service transactions. That's requests for a token for, what's that, $20 a month. So if I have 1 million in the month, it's going to cost me $20. It's not much, really. Service Bus, similarly. Have they got Service Bus on here? Yes. So, Service Bus. So messages. Right, 2 million messages costs you $21.90. Oh, sorry, access. Oh, sorry, I've left my access control on that. Yeah. Sorry, 2 million messages cost. Oh, that's a bit too expensive. Costs you $2. Yeah. If you're using Relay, then Relay's done in hours. I'll have to do it. Relay's done in hours. Yeah. Oh, that's better. Yeah. So I'm not quite sure how that works out, but it's clearly a divisor of that, isn't it? So 100th, is it? Must be 1 cent an hour, isn't it, or something like that? Is that 1 cent an hour? No, 1/10 of a cent an hour.
That's half a year, about 3,800.
3,800 hours costs me $3.81 a month. So I'll do the maths. It's too late.
So that's not based on how many messages you relay.
No, that's based on the number of hours of relay.
If you do 1 year of relay, you do 100,000.
Yeah, but if you have 100 relays,
It's per client.
Yeah. Because you could have, I could have the Twitter service, the Google service, the Bing service, the Uncle Tom Cobley service. These would all be things that would add to my relay. So if I only had one service and it was up for an hour, that's 1 hour. If I had 10 endpoints, that would be 10 hours worth of relay. Yeah.
But still, that's about $5 or $6 a year.
Yeah, not very much. Absolutely. Plus the exorbitant messaging, of 165 million messages. Actually, that's not that many, really. So you're looking at, what is that? That's $1 per million messages or something like that, isn't it? Yeah. But then again, if you're doing, I don't know, how many messages get sent through Hotmail every day? Billions. Yeah. Okay. A good point to stop, I think, guys. Yes? Has it made some sense? Excellent. We have one last one to go, which is around hybrid apps, which I think we're due off at 5:30. Is that right? I think it's 5:30. Okay. See you then.